to study the phenomenon of photoelectric effect. My name is Saroj Sengtan, Central Department of Physics, Kirtipur, Kathmandu, Nepal. Firstly, abstract section. The importance of doing practical is to understanding concept and principle of the subject, to show connection between action and observation, to acquisition of personal and professional skills, and to enable independent learning. Here we explain the phenomenon of photoelectric effect in the simple and most convincing way, virtually by using the computer simulations. The main purpose of this experiment is to understand the photoelectric effect due to the interaction of photon and electron present in the metals. And we study the stopping potential, work function, Planck constant, and graph connecting between the kinetic energy of the photoelectron versus frequency of the incident radiations, and also photocurrent versus applied potentials. Keyword of the experiment are photoelectric effect, Planck constant, work function, threshold frequency, stopping potential, etc. Aim of this experiment are: number 1, to understand the phenomenon of photoelectric effect as a whole. Number 2, to draw kinetic energy of photoelectron as a work function as a function of frequency of incident radiation. Number 3, to determine the Planck constants from kinetic energy versus frequency graph. Number 4, to plot a graph connecting photocurrent and applied potentials. Number 5, to determine the stopping potential from the photocurrent versus applied potential graph. Apparatus required: light source, evacuated tube, emitter, voltmeter, battery, and rheostat. Theory of the photoelectric effect. Photoelectric effect is the emission of electron when electromagnetic radiation having sufficient frequency incident on the certain metal surface. We call the emitted electron as a photoelectrons and the current they constitute as photocurrent. The phenomenon was first observed by Heinrich Hertz in 1880 and explained by Albert Einstein in 1905 using Max Planck quantum theory of light. A simple experimental arrangement is shown in the figure right side. It consists of the two zinc plates C and D enclosed in an evacuated quartz bulb and connected to the battery, emitter and voltmeter. When ultraviolet rays are made of fall on the negative plate, immediately current flow in the circuits. The stopping voltage refers to the voltage difference required to stop the electron from moving across the plate in the photoelectric effect. When light is directed at the metal plate, if the frequency of light is high enough, electron will be ejected from metal plate and will travel across the cathode. Suppose we add the variable voltage source to the circuit so that it creates a negative charge on the cathode plate. The electron ejected from anode will be repelled by negative cathode. If we increase the variable of the voltage of the variable voltage sources, there will be increase in the electric repulsion forces between ejected electron and negative cathode. Eventually, at a point is reached when electrons have not sufficient kinetic energy to move across the plate. This is the stopping voltage. The stopping voltage is radially used to determine the kinetic energy that the electrons have as they are ejected from the metal plate. The product of the charge of the electron and stopping voltage give us the maximum kinetic energy of the ejected electron. Laws of photoelectric emission. Number 1. The strength of the photoelectric current is directly proportional to the intensity of light. Number 2. The stopping potential or maximum kinetic energy of the photoelectron is independent of intensity of incident light. Number 3. The maximum kinetic energy of photoelectron is directly proportional to the frequency of incident light. Number 4. Light of frequency lower than that of threshold frequency never sets free photoelectron from metals, no matter how long it falls on the metal. Number 5. The threshold frequency, which defines the lower limit to photoelectric emission, is characteristics of emitter. Its value varies from substance to substance. The minimum amount of energy required to eject the electron from the metal surface is called work function of the metal. If W be the work function and m be the mass of electron and p be the velocity of electron, then total energy of the photon is equal to work function plus kinetic energy of electron. Here, total energy of photon is S nu is equal to work function is equal to S nu naught plus nu naught is the threshold frequency plus kinetic energy is 1 by 2 mv square, and we arrange this equation. Kinetic energy is equal to 1 by 2 mv square and 1 by 2 mv also E into V. The equation becomes V is equal to S nu divided by electric charge E minus S nu naught divided by electric charge E. This is said to be equation 2. This equation 2 is similar to straight line equation y is equal to mx plus c. Here slope is equal to s by e and negative intercept is equal to minus s nu naught by e. Observations. All the data are taken by using the computer simulator, which is obtained by virtual lab of Amrita Educations, which link is given in below in references. Here first observation table is between the applied voltage and current of constant frequency f is equal to 2 petahertz at different intensities. Here we have given table and graph. All the data is can be taken by computer using the computer simulator and drawn the graph of the above table. Secondly, second table observation table is between the applied potential and current at the constant intensity for different frequencies. Here all the data are taken by computer simulator of virtual lab of Amrita Educations and draw the graph of above table. We get the graph like this, and observation table number 3 is observation table for 3 is for frequency and stopping potential at a constant intensities. Here we get the data table like this. We can easily obtain this data by using the computer simulator of Amrita Education Virtual Lab, and also plot the graph of this maximum kinetic energy versus frequencies. We get the graph like this, and now calculation part. All the calculation is done by the above observation. So we have to use the table from table 1 to obtain the stopping potential with respect to the given intensities. We get the stopping potential from the graph 1 and from the table 1, that is stopping potential is equal to the 4 volt. We know the stopping potential is potential required to stop the electron from the anode, that is it stops to flow the current in the circuit. And from table 2 we calculate the stopping potential at intensities I is equal to 10 watt per meter square, but for frequency is equal to 3 petahertz, that is we get the stopping potential 8.6 volt, and intensity for intensity 10 watt per meter square and frequency 2 petahertz, we get the stopping potential 4 volt, and we calculate the stopping potential at different frequency and different intensities. Then we have to calculate the Planck constant. We calculate the Planck constant by using the table 3. Here we have taken the different metals like copper, sodium. For copper, we know that slope is equal to S by E, which is from equation 1, and S is equal to slope into E. Then we can find the slope slope by the graph 3, we get the slope is equal to 4.2 petahertz. Therefore, we can easily obtain the Planck constant yachts. Planck constant is equal to slope into electron charge. That is, we obtain the Planck constant is equal to 6.85 into 10 to the power minus 34 joule for copper. Similarly, like that, for sodium, we get the Planck constant is equal to 6.85 into 10 to the power minus 34 joule second. Yes. B. To calculate the work function of copper and sodium, we know the formula. Work function is equal to h nu, but we don't know threshold frequency nu naught. Threshold frequency can be obtained by intercept is equal to H nu naught by E. We know the value of H and E and also intercept. So we can calculate the value of nu naught by using all the data of H, E and intercept. Then we find the nu naught is equal to 1.13 petahertz for the copper. So finally we calculate the work function. W is equal to H nu naught. That is, we get the result 4.66 electron volt. Similarly, we obtain the work function of sodium by using the intercept formula, and finally using the work function formula. That is, we get the work function of sodium is equal to 2.22 electron volt. Now we come to the result. Here, first result, all the photoelectric laws are verified by the graph and calculation part, by using a graph and calculation part. And second, we find the Planck constant, that is H is equal to 6.85 into 10 to the power minus 13 joule second. And stopping potential and the value of work function for copper and sodium are 4.66 electron volt and 2.22 electron volt. And stopping potential for copper at frequency 3 petahertz is equal to 4 volt. And error, we find the error for Planck constant and work functions for different material. For Planck constant error, we find the relative error. We know the formula of relative error is equal to calculated value minus truth value whole divided by truth value. We used this formula. We know the calculated value of Planck constant is equal to 6.85 into 10 to the power minus 34 joule second, and we know the truth value of Earth's Planck constant is equal to 6.626 into 10 to the power minus 34 joule second. So by using this calculated value and truth value, we find the relative error in the Planck constant. That is, we found the relative error in the Planck constant is equal to 3%. Similarly, like that, work function error in work function will be calculated. Error in the work function will be calculated using the truth value and calculated value. We found the relative error for the work function of different material. For sodium, we found the error 3% and for copper 1%. Now we come to the conclusion and discussion part. Conclusion and discussion can be done from using the graph 1. By using the graph 1, it is found that the current is directly proportional to the intensity of incident light. That is, if intensity of incident light is increases, then current will be increases. And from graph 2, it is found that kinetic energy of electron is directly proportional to the frequency of incident light. That is, maximum kinetic energy increases as the frequency increases. Similarly, from graph 3, it is found that threshold frequency for both metal are different. So there will be different threshold frequency for different metal for particular incident radiation. that is work function of different metal is different. Now, acknowledgement. I would like to acknowledge this virtual lab work to respected dean, head, all faculties, laboratory supporting staffs, administrative staff, and all my classmates. References. I use the different references material to understand and complete this experiment. I use the Modern Physics by R. Morrison to understand the theory of the experiment. And I use the virtual lab of Amrita Education to collect all the data and observations. And also we use the different material like internet, YouTube's, and other books also. Now, appendix part. In appendix part A, work function of different metal are tabulated below. Here, different elements are given and different work function are given. And appendix B, I have attached some question and answer for appendix B. Here, question number 1. What is photoelectric effect? The phenomenon in which electrically charged particles are released from or within a material when it absorbs the electromagnetic radiations. And question number 2. What is virtual experiment? We have to know what is the virtual experiment. Here, experiment done by using the multimedia application which allow video and digital simulations of laboratory activities in a real manner but without the risks and cost associated with laboratory experiment. Who discovered photoelectric effect? The photoelectric effect was first discovered by Heinrich Hertz in 1887 and later by Albert Einstein in 1905. What is threshold frequency? The minimum frequency of radiation that will produce a photoelectric effect. What is work function of metals? The minimum quantity of energy which is required to remove an electron to infinity from the surface of given material. Thank you.